Hello, it's Connor from Breakthrough Maths. Here I have an Edexcel higher predicted paper. This is for paper 1, and this is a non-calculated paper. I am just going to dive straight into it, run through the solutions, okay? So 24x cubed over 4x, 24x to the 3, divided by 4x. Straight away we can see that those x's are going to cancel, leaving us with x squared on the top of the fraction. 24 over 4 is 6, so 6x squared is our final answer. Okay, find 24.5 times by 5.4. Different methods of this, so I'm going to go with the grid method, okay? So 20 and 4 and 0.5, and then a 5 down the side, and a 0.4. Lovely. So 5 times 20, that's going to give us 100. 5 times 4 gives us 20. 5 times 5 divided by 10, 2.5. 4 times 2 is 8, times 10, divide by 10, 8. 4 times 4 is 16, divide by that 10 there, 1.6. And a 4 times 5 gives us 20, divided by 100, 0.2. Now to add all of these up, 100, 20, got 8, 2.5, 1.6, and a 0.2. Okay. 5 and 6, 11, 13, carry out a 1, 8, 9, 10, 11, 12, 2, carry the 1, 3, 1. Okay, final answer 132.3. Lovely. So question 3, a straight line has the equation y equals mx plus c, and the line passes through the points 1, 5 and 3, 6. Find the gradient m of a line. So we know that the gradient m is equal to the change in y over the change in x. So y2 minus y1 over x2 minus x1. Subbing in our values for our 2 points, we've got 6 minus 5 over 3 minus 1. That leaves us with 1 over 2, so we have a gradient of a half. Hence, find the value of c. Find the y-intercept now. We can choose one of the points. Let's go with 1, 5. So y equals mx plus c, 5 equals to m 1 half times by x, which is 1, plus c. Let's rearrange for c. We know we can move the half times 1 becomes a half. Moving the half to the other side, we've got 5. Take away 1 over 2, which is 10 over 2 minus 1 over 2, which is 9 over 2, or 4.5 for our y-intercept. Okay? Okay, question 4. A solid shape has a volume of 2,400 millimeters cubed. What is its volume in centimeters cubed? Well, we know that 1 centimeter is equal to 10 millimeters. And 1 centimeter cubed is equal to 10 millimeter cubed. So 1 cubic centimeter is 1,000 cubic millimeters, okay? So, but we don't have 1,000 millimeter cubed, we have 2,400, but it's just a simple conversion. We know that 1,000 millimeters cubed is equal to 1 centimeter cubed. Then we have 2,400 millimeter cubed, but we don't know what that is in centimeter cubed yet. All we need to do is look at what we multiply by to get from 1,000 to 2,400, and that's 2.4. Whatever we're multiplying up on the left side, we're going to do the same to the right-hand side, okay? Times 2.4. So our answer is 2.4 centimeters cubed. Okay. Question 5. A is 50% of B and B is 25% of C. What percentage of C is A? Well, so A is 50% of B, that's 0.5 B. And B is 25% of C, which is 0.25 C. But if B is 0.25 C, then we can just substitute 0.25 C into B here for the equation for A. So A is 0.5 times by 0.25 C. Now half of 0.25 is 0.125c. So we've been working in percentage multipliers. Let's just change them back into percentages by timesing that by 100. So 0.125 times 100 is 12.5%. Final answer, 12.5%. Cool. Question 6. By rounding values to one significant figure, estimate the value of 28.2 times by 48.56, given your answer to one significant figure. Show the numbers you use to work out your estimate. Okay, so 28.2 to one significant figure is going to be 30. 48.56 to one significant figure is going to be 50. So we're going to do the calculation of 30 times by 50. 3 times 5, 15, adding on our 2 tens, 1500. But give your answer to one significant figure as well. 1500 rounded to one significant figure is going to round up to 2000. Lovely jubbly. Okay, question 7. The diagram shows a square, PQRS. The square has been divided into smaller squares and isosceles triangles. What fraction of the square PQRS has been shaded? Okay, this one's going to get a little bit messy, so stay with me. If we say that the area of PQRS is equal to 1, it's one whole, then we can work in fractions for the rest of the question. So the PQRS is split into 4 boxes to begin with, so each box has an area of 1/4. Okay. Now we can divide one of these squares into 2 by drawing a diagonal line, 2 triangles. So each triangle now in this square here has an area of 1/8. We divided it into 2. The fraction gets 2 times smaller, 1/8. But we can also divide it into 4 smaller squares. So if this area is 1/4, dividing that by 4, then each of these areas is going to be 1/16. And if we divide those even further, then 1/16 into a quarter divided by 4 is going to be 1/64. Okay? Now let's look at the section that we're interested in, the shaded regions. We know that we can split this up. This is going to be 1/16. And if we move this black triangle here up to the left, then an entire corner is shaded, which gives us 1/16 shaded. Okay. So these 2 triangles here, 1 and 2, they're going to be 1/16 of the area. So I'm going to make a note of that down here, 1/16. Now zooming in a little bit further, we can see that it's not that we're interested in half of 1/16 now. So this region here is going to be 1/32. Okay. So if we write 1/32, which is half of a 16th, but there's a box clearly not shaded here, but we've previously worked out that that's going to be 1/64. So we've got 1/32, but we're not interested in 1/64 of it. So 1/32 minus 164 is going to be 2/64 minus 1/64, giving us 1/64. So these 2 triangles down here add up to 1/64. So if we add all that together, 1/16 add 1/64, we can multiply that first fraction by 4, 4/4, which gives us 4/64 plus 1/64, which gives us 5/64 for the total shaded area of this square PQRS. Okay, question 8. So the nth term of a sequence is given by the formula n squared plus 3n is 4, and we were asked, is the fifth term in the sequence a prime number? Show how you worked out your answer. So the nth term expression, the formula, we can just sub in 5 for the fifth term. So 5 squared plus 3 times 5 plus 4. We've got 25 plus 15 plus 4. 25, 30, 44. Is the fifth term in the sequence a prime number? Is 44 a prime number? Well, straight away we can see that 44 is divisible by 2, leaving us with 22. So no, it is not prime, because it's an even number. There's only one even prime, and that's number 2. A different sequence begins 3, 6, 11, 18, and 27. Write down the next 2 terms in the sequence. So what is the difference between each term? 3 to 6, we're going to add 3. 6 to 11, we're adding 5. 11 to 18, we're adding 7. Then 18 to 27, we're adding 9. What is the difference between the difference? 3, 5, 7, and 9. Well, these are all odd numbers that are going up into 2. Write down the next 2 terms in the sequence. Well, I think we're going to be adding 11 and then adding 13. So 27 add 11 is equal to 38. And then 38 add 13 is 51. 2 terms, 38 and 51. Okay. Now, we have a Venn diagram. We've got a universal set, 1, 2, 3, all the way up to 18. We've got circle A, set A. X is between 4 and 9 inclusive. And then for set B, X is a factor of 18. Let's complete the Venn diagram to show the elements of each set. So let's write them out first. In set A, we're going to have 4, 5, all the way up to 9, 6, 7, 8, 9. And for B, X is a factor of 18. So what factors of 18 have we got? We've got 1, 2, 3. We've got 6, 9, and 18 itself. Okay, let's start with the cross section, right? So A and B both share a 6, and they both share a 9. Now in A, we're going to have 4, 5, 7, and 8. 4, 5, 7, and 8, and then 1, 2, 3, and 18. 1, 2, 3, and 18 in B. Now the universal set is the numbers 1 to 18, so every number that isn't included already is going to go outside in the box. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We haven't got 10, so 10, 11, 12, 13, 14, 15, 16, and 17. There's 18 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yep, 18 numbers. There we go. Perfect. Question 10. Find values of P and Q such that 4P plus 3Q is 22 and 3P plus 2Q is 16. So, simultaneous equations. What do we need to do? We need to make the coefficient of one of the unknowns equal. Let's multiply equation 1 by 2 and equation 2 by 3 to make these the same. So when you multiply 2 coefficients together, you're going to find a common multiple, right? So rewriting that, we've got 8P plus 6Q is equal to 44. And then the second one by 3, we've got 9P plus 6Q equals 2. So it's 18, 48. So I am going to do 2 away from 1. You can subtract them in any order. It's just I'm going to avoid a minus sign. So this is leaving us with 1P. This goes to 0. Equals to 4. P is 4. So if P is 4, let's substitute it back into an equation. I'm going to use equation 2. 3 times by 4 plus 2Q equals to 16. So 12 plus 2Q is 16. 2q is equal to, let's take 12 both sides, we've got 4. 2q is 4, 1q is 2. So p is 4 and q is 2. Fantastic. Okay, question 11. Work out the highest common factor of q and r. So we've got p is 2 squared times by 3 cubed times by 7. It's prime factors. P represented as a product of its prime factors. Q is 8/9 of p, and r is 4 over 21 times p. So let's convert the equations for q and p, the expressions for q and p, into prime factorization. So q is 8 over 9 times p, but 8 is 2 cubed. So 2 times 2 times 2. 9 is 3 times 3. And that's times p, so I'm just going to substitute it in. 2 squared times by 3 cubed times by 7. Now r is 4 over 21. So 4 is 2 times 2. 21 is 3 times 7. Okay. And that's again times by p. 2 squared times by 3 cubed times by 7. Now what can we how can we simplify this? What cancels out? What adds together? So we've got 3 more 2's. I can add to that. So this is going to be 2 to the 5 now. And then we're taking 2 3's away from this 3 cubed. So 2 to the 5 times by 3 to the 1 times by 7. Then we've got 2 more 2's on the 2, 2 to the 4. And then we're taking a 3 away, so it's 3 squared. And then we're taking a 7 away. Okay? So now for the highest common factor, we're going to use the lowest power of shared primes. Highest common factor. Lowest power of shared primes. Okay, so what have we got? We've got shared primes of 2 and 3. So we're going to use 2 to the 4 and 3 to the 1. So 2 to the power of 4 times by 3. We know that 2 to the 3 is 8 times by 2 again. We've got 16 times by 3. So that's 16 times by 3, which gives us 48 as the highest common factor of Q and R. Fantastic. Okay. Question 12, what have we got here? The scale drawing shows the position of 3 shops, S, Q and R, on a map. The scale is 1 square is 10 miles. Okay, so an ambulance takes a patient to shop S if they are within a 30-mile radius of this shop. Otherwise, it will take the patient to shop Q or R, depending on which is closer. A person calls from their home and is taken to shop Q. Show on the map the region where the person could live. So we would ideally have a protractor, right? Be able to draw a nice circle because we're given a radius, 30-mile radius. So 1 square is 30 miles. So 1 square is 10 miles. So 30 miles is going to be 3 squares, right? So if I can do my best, 1, 2, 3 here, 1, 2, 3 around S, 1, 2, 3, 1, 2, 3. By freehand, the best I can do. There we go. And then we're also told that it will take the patient to shop Q or R depending on which is closest. So if we join Q and R, a bit better than that, join Q and R, and if we find the perpendicular bisector, so right in the center, the perpendicular line at 90 degrees means that all of these points are at equal distance, right? So shading in the region where they're taken to Q, it's just going to be this region here. Lovely. Cool. Question 13. Find 6 times 10 to the 5 times by 4 times 10 to the minus 3 and give your answer in standard form. So what we can do is just do the 6 times 4 and then multiply that by 10 to the 5 times 10 to the minus 3. 6 times 4 is 24, and we're going to times that by. So these powers have, these numbers have the same base 10, and when we're multiplying two numbers of the same base, we add the powers. So we've got 5 plus minus 3. 5 take 3, which is 2. So 24 times 10 to the 2. Now, is this in standard form? No, it is not, because 24 is greater than 10. We have to have this number here between 1 and 10. It can include 1, it can't include 10. Because if it includes 10, we can just take another 10 out and increase that power. So that's what I'm going to do. 2.4 times by 10, and we're increasing this power because we've taken 1 here. 3. 2.4 times 10 to the 3. Final answer. Right. Question 14. A block of metal with a weight of 84 newtons is resting on a flat table. The base of the block is flat and has an area of 140 centimeters squared. Find the pressure exerted by the block on the table, giving your answer in newtons per centimeter squared. Perfect. So, pressure, the equation for pressure is force over area. The force, weight is a force and it's measured in newtons. Force is 84 and the area, divided by the area, 140 centimeters squared. So we can divide by 7 to simplify this fraction, top and bottom. So we get 12 over 20. And then we can divide by 2 top and bottom to get 6 over 10, leaving us with 0.6 newtons per centimeter squared. Don't forget your units. Okay, question 15. A company bought an antique sculpture in 2015. In January 2016, the sculpture was worth 15% more than when the company bought it. In January 2017, the sculpture was worth 25% less than in January 2016. And a newspaper report said overall the value of the sculpture decreased by 15% between 2015 and 2017. Was the newspaper correct? Okay. Let's say that the original price, the original worth, was X, and in 2016 the sculpture was worth 15% more. So this is 0.15, or 15 over 100, right? 15 over 100, we can divide that by 5, so we've got 3 over 20. The sculpture was worth 25%. Straight away, we know that that is a quarter, right? And then we've got a 15% here, 3 over 20 again. So let's map this out. In 2015, the sculpture. In 2015, the sculpture was worth X, and in 2016, it was worth 15% more. So we have X plus 3 over 20 X. So this is 20 over 20 plus 3 over 20. That gives us 23 over 20 X. In 2017, the sculpture was worth 25% less than in 2016. So 25% less, we're gonna multiply by 3 over 4, because 3/4 is 25% less than a whole, right? So 23 over 20, I'm just going to multiply by 3 over 4, lots of X. So 3 times 23 is 69, and 4 times 20 is 80. So that's how much it was worth in 2017. Now, the newspaper report says that overall the value decreased by 15%. So we need to check the difference between the starting value and the value in 2017. So our calculation is X minus 69 over 80X. If we turn this into 80 over 80, which is just 1, 80 over 80 is 1, no change there, then we're left with 11 over 80X. So this is the difference the difference, right? But the newspaper said that the sculpture decreased by 15%, but we've worked out 11, which would be 3 over 20, but we worked it out to be 11 over 18, which is not equal to 3 over 20 or 15%. So no, newspaper is not correct. Okay, question 16. The diagram shows a circle P and a sector Q. Show that the area of P is twice the area of Q. What is the area of a circle? It is pi r squared. Pi r squared. So what's the area of P? We have pi times by 3 squared. That gives us 9 pi straight away. Cool. Now the area of, well, let's assume an entire circle first, then we'll focus down into the sector itself. Pi r squared, we've got pi times by 6 squared. That gives us 36 pi. But we only have 45 degrees of this out of the whole 360. So what we do is we find the fraction of this sector to the whole. 45 over 360, and then we're going to multiply that by our calculated area of 36 pi. 45 over 360, well, 8 45s go into 360, so that's 1/8. So this becomes 1 over 8 times by 36 pi. 8 goes into 32 with a remainder of 4. So this is, the area here is 4.5 pi. So, show that the area of P is twice the area of Q. Well, P is 9 pi, and Q is 4.5 pi. So 9 pi equals to 2 times 4.5 pi, which is P equals to 2 times Q. Perfect. Question 17. Calculate 3 3/4 divided by a half, take away 5 over 6. So let's convert our mixed number now into an improper fraction. 3 times 4 is 12. Add the 3. We've got 15 over 4. Dividing by a half is the same as timesing by 2. So that gives us 30 over 4, which is 15 over 2. 15 over 2, take away 5/6. Let's multiply this 15 over 2 by 3 over 3. And that gives us 45 over 6, take away 5 over 6. And that leaves us with 40 over 6, which is 20 over 3, which we could leave as a final answer, or we can turn it back into a mixed number. So 3 goes into 18 6 times. So we've got 6, and then 2 remainder, 6 2/3. Okay. Question 18. The mean of 7 numbers is 15. 2 of them are 10 and 15, while the remaining 5 numbers are all equal. What is the value of each of the 5 equal numbers? So the mean is where we add up all the numbers and divide by how many there are. So let's call the sum of all the numbers x. The mean of 7 numbers is 15, so x divided by 7, the 7 numbers, is 15. So we can rearrange this for x to find the sum of all the numbers. X is equal to 7 times 15. 7 times 15 is 105. We know that 2 of the numbers are actually 10 and 15, so we can do 105, take away 10, take away 15, which will leave us with 80. And now we're told that the remaining 5 numbers are all equal, so we can just now do 80 over 5, which is 16. So each of the 5 equal numbers, yeah, all 5 numbers are 16. Cool. Question 19. The temperature at midnight was -7 degrees Celsius, and it increased by 4 degrees every 3 hours. What will the temperature be at 9 a.m. in the next morning? Midnight is 12. So from 12 to 9, that's 9 hours. And it increased by 4 degrees every 3 hours. So if we do 9 over 3, that is 3. When we know that it increased temperature 3 times. And it increases by 4 degrees. So 3 times by 4 gives us 12 degree, a 12 degree increase. If we were starting at -7 and we're adding 12, that gives us 5 degrees Celsius. 5 degrees at 9 a.m. Okay. Question 20. Write 8 over root 5 plus root 45 in the form of k root 5. So we don't like to have surds on the denominator. So what I'm going to do is do 8 over root 5 times by root 5 over root 5, which is just 1. Anything divided by itself is 1, so we're not actually changing the fraction, we're just changing the way it looks. 8 times root 5 is 8 root 5. And root 5 times root 5, whenever you've got a surd that's being multiplied by itself, the square root symbols just cancel. So if we have a look up here, root 5 times root 5 is root 5 times 5, which is root 25, which again is just 5. So whenever you see we have surds the same multiplying together, it just cancels out. So we've got a 5 here, and then root 45. Well, root 45 can be divisible by 5 and 9. So let's do root 9 times 5. Root 9 is 3. So root 45 is 3 root 5. So adding that on, 3 root 5. Now, we need to have the same denominator to be able to add these together. So let's multiply this by 5 over 5. That would give us 8 root 5 over 5 plus 15 root 5 over 5, and that would giving us 23 over 5 root 5, where k is 23 over 5. Final answer. Okay. Question 21. Rearrange the formula v equals to 12 times by s plus 3t all over 5t. We need to make s the subject. Okay, s. So v, I'm going to multiply both sides straight away by 5t. So that leaves us with 5vt equals to 12 s plus 3t. Now I'm trying to isolate s, so I'm going to divide both sides by 12. 5vt over 12 is equal to s plus 3t. And now I can take 3t from both sides to leave s by itself. S is equal to 5vt over 12 minus 3t. Okay, part B. A car travels s meters in t seconds, and its speed v is given by the formula in part A. A second car travels d meters in t seconds, so that d is directly proportional to t squared, and it travels 225 meters in 10 seconds. After 6 seconds, the two cars have traveled the same distance. Calculate the value of v at this time. Okay, what is this telling us? So d is directly proportional to t squared, like this. D is directly proportional to t squared, so that means that d is equal to some constant of proportionality, k, times by t squared. And if it travels 225 meters in 10 seconds, then we can sub that in and get k. So k is equal to d over t squared, which if we plug in 225 over 10, which is 100, then we know that k is equal to 2.25, or fractional form 9 over 4. Okay. After 6 seconds, the two cars have traveled the same distance. So what is that distance? If d is equal to 9 over 4 t squared. What is 9 over 4 times by 6 squared times by 36? (36 over 4 is 9. 9 times 9 is 81.